All right, how's it going, everybody? So I'm going to be going over this engineering labor market document. So here's some important context that I forgot to mention at the start of the video. Those who are not working as engineers and were working in positions that do not necessarily require a degree made up 33% of the total number of engineering degree holders in Ontario. So when you see me cite 33%, this is where I got that number from. Additionally, according to the 2011 National Household Survey, only 30% of employed individuals in Ontario who held a bachelor's degree or higher in engineering were working as engineers or engineering managers. So, two-thirds of engineering degree holders were not working in engineering at all. So, those are kind of the main points that I'm basing this entire video off of, and let's get into it. And while you're here, don't forget to like and subscribe. Thanks. The main starting points that they kind of wanted to study are we graduating too many engineers? Are a lack of co-op positions a primary reason why many engineering graduates cannot find work as engineers? Are some of the 33% simply never going to find work because of reasons other than demonstrable skills? Given the high rate of underemployment, why does the government and some industry leaders believe there is a shortage of engineers in the province? So there's a bunch of these really interesting questions that hopefully this document will be able to answer. And if you missed the first part, underemployment is a state of employment in which an individual with an engineering degree is employed in a job that does not necessarily require a university degree. If I go into construction or lawn care, then I could still be considered underemployed, even though you're running a small business and you might be employing other people. You're still technically not putting your engineering degree to use. So there is definitely a line between what's considered as underemployment and whether or not you're getting by. Here's a point that I thought was really important to make, which is it seems reasonable to ask why society would invest thousands of dollars in full-time university education for individuals who are happy with jobs that do not require a university degree. These individuals might be better served at much lower cost by allowing them to attend specific courses of interest at the university level while they are working. So that's, I think, pretty important because the federal and provincial government, wherever you are, they do pay for education and for people to go to school. They subsidize a lot of the cost, which is why you'll see in international tuition, it's like 4 times more expensive than domestic tuition. And the reason is because the governments don't subsidize any of the cost for international students. So the question is, if there's so many people going to university getting engineering degrees, we're putting up so much more money, and it's a really inefficient use of that money for a third of engineering students to get an engineering degree and then not use it when they could have just gotten a lower level, less expensive degree that put the provincial and federal government's money to better use. And I think that this kind of just shows that there is like a mismatch between multiple things, but mainly there's a mismatch between the supply and demand. And there's so much more demand for these degrees than there is supply of jobs. And on top of that, there's also a mismatch of the way that people select a degree. When you're 18, you have no clue what you want to do, and that's just a fact. And I'm probably going to change my mind like 5 or 6 more times before I finally decide on something that I want to do. And then even after that, I don't know, I might change my mind another 5 years down the line. I think that it should be more widely accepted and allowed to maybe change your mind, or it should be very common for people to take a gap year so they can go sit their butts down, read. I guess they can go abroad, do whatever, but figure out the things that they enjoy. Because while you're in high school, you don't really know what you want from your future. It is kind of hard to just like pick something and stick with it. Most people just end up picking what they think they'll be good at, which happens to be engineering. Point is that this is an inefficient use of government money. I also read a study. I'm going to go find it. So I read this study from 2017. It's an investigation of the state of creativity and critical thinking in engineering undergraduates. And essentially, if you go through the abstract here, you see that there is evidence of decreasing creativity and critical thinking in senior engineering students. And if you go through and you actually read this study, you'll see that in multiple parts, they show how engineering actually might have the effect of decreasing or at least keeping your problem solving skills and your critical thinking skills completely stagnant throughout the degree. You don't really learn how to do abstract thinking or anything because all you're doing is reading textbooks and learning how to think in one very linear format. So here's a chart of the critical thinking scores So we have freshmen and we have seniors, so first year and fourth year. According to this study, which obviously you kind of have to take all studies with like a little bit of caution, but according to this study, on this test, which is like a critical thinking test, engineers scored 57.76 in their freshman year and 53.8 in their senior year, which means their critical thinking skills actually declined over the course of their 4 years. Meanwhile, they did a like normative sample, so just a test sample of a bunch of other degrees. Their critical thinking skills actually went up during their university time, which is what's supposed to happen. Let's see if we can get the numbers. Okay, so here's the freshman scores. There's 59 engineers, and then here are the senior scores. There's 86 engineers compared to a normative of 824 freshmen and 417 upper year students. And I think it could also be that if you're not in engineering, you don't exactly enter university with the greatest critical thinking skills, which is why they scored 53.8 on this test. And then over time in university, they got significantly better. But with engineering, they entered with great critical thinking skills. And my personal reasoning for maybe why this would go down is because you're not really trained to do very much critical thinking in engineering. You're just told and taught how to perform certain equations, and there isn't really too many abstract or design thinking courses. I think I did one design thinking course in my 3 years so far, and I think that it should be a annual thing that engineers do design thinking courses. Anyway, so this entire study is very interesting. If you go through it and you look at the tests and how they actually evaluate the tests, the TCT, DP, and WGCTA tests, test of creativity, thinking, drawing, production. So that's this one. And then the WGCTA is the Walterson Glaser Critical Thinking Appraisal. So both of these tests have been used, I guess, somewhat extensively in trying to evaluate these things. Yeah, let's go back to this Ontario OSPE thing, because this chart here, which is very interesting, is match rates of employment of employed individuals in the corresponding occupation as of 2006. Match rate is essentially you got the degree and you got the job. How closely are you matched to the job that your degree says? And in all of these medical professions, it's at least 70%. Even veterinary medicine is 70%. And then once you get to law and teaching, it starts to go down. But engineering and accounting, two fields which I'm interested in, are both at the very bottom here of match rate, which could be a problem. But when I was thinking about this, like abstractly using my non-existent critical thinking skills, I recently read a book called Range, and it essentially states that people in their youth, so like, between 18 and 29, change their mind all the time, still developing, still trying to figure out exactly what it is they want to do. And usually engineering or accounting are the first degrees that a person will get from university. And because of this, since they're the first degrees, even architecture or diet, because these are the first degrees that somebody will get in university, and if we go up the list here, all of these require, maybe except nursing, all of these require a like a graduate degree or a postgraduate degree in order to end up in these professions, which means that all of these people could have had one of these undergraduate degrees and then decided after their undergraduate degrees that they didn't like the field and went on to do a higher education, which I think really kind of shows that as you get older and as you kind of decide exactly what it is that you want to do, your match rate will increase like crazy because you've had time in your undergraduate degree, whatever it is that you chose to do, to explore various different things that might interest you. So you've had time to think about it, and you end up taking a graduate degree of something that you're really interested in. And that causes your match rate to go way up because most of these graduate degrees, not all of them, but some of them are 2 years, most of them 4 to 6 years. But once you've reached that point of deciding that this is something that you're going to do for a longer term of your life rather than the absolute first degree that you step into, I think it's more likely that either one, you really want to find a job because you have so much more sunk cost and time into it, or two, your personal match with the your personal match with the career actually increases because you've had time to think it over and explore throughout your undergraduate degree. So I don't think that this really poor match rate here is a problem, because the way I see it is that smart people just kind of go into engineering and they don't really consider whether or not they're going to like it. And they just do it because everybody's telling them to do it, and because they think it'll be a good degree and it'll secure a good future. And they're probably right in thinking that, but most of the time, you're going to find your match a lot later on. So after even like 6, 8 years of school rather than just 4. So it is very interesting to kind of take a look at this and see and maybe notice some of the things that the paper doesn't exactly show, which is that some people, because engineering is your first undergraduate degree, it's likely that you won't find your match immediately. Now, outside of that, if you look at the second chart, so this is from since 1996 to 2011, there are so many more degrees in engineering. There has been some job growth here, actually declined between 2006 and 2011, but there is no slowing down in the engineering degrees that we're printing. So this red line either needs to shoot straight up, or this blue line needs to flatten out and even come down. I think we need to start directing people towards different degrees that they will actually find useful and enjoy, because the amount of people that are just like absolutely brutalizing their mental health just to do an engineering degree, whether or not they actually want to do it, I think there is a much, much better way and system that would help these people out. But then you have to consider the other side of the problem, which is that if you are the only person without the engineering degree, then you start to look bad compared to everybody else with the engineering degree, because everybody covets engineering degrees, including employers. So this has to be an across the board initiative that people have to decide that, okay, we're going to take engineering degrees and we're going to try to redistribute these people into fields that they will actually like, into things that they will actually want to do. But on top of that, you have to make sure that there are jobs for all of those other people who decide against going into engineering, because right now engineering is your best bet of not being underemployed. There are so many arts and science majors from other different fields that are way more underemployed than engineers. And it could be because, unlike the paper I just showed you, engineers do actually learn some form of critical thinking and some form of abstract thinking that allows them to apply their skills in various different ways. And obviously, I'm saying this and like I showed you that study, but that doesn't mean that the study is perfectly correct. You just have to take everything with a grain of salt. And in my experience, engineers are very good and resilient at kind of adjusting to the task at hand. So that's a very good thing that you get from an engineering degree that you might not get from other degrees. So, as we see from this paragraph here, as of the 2011 National Household Survey, approximately 65% of employed Ontarians with engineering degrees were gainfully employed in professions that require or benefit from having a university degree. Here are some other things that are some other causes of the high underemployment rates. There might be an excess supply of engineers, too few engineering jobs being created. Employers want specialized knowledge and skills before they will hire an engineer because they want to avoid on time job training. Universities are graduating engineers with insufficient job related skills, so they're not giving them co op opportunities or anything like that. They're not like giving them classes to help them build their practical and communication skills, because believe it or not, you need to do that for engineers. Their writing and typing skills aren't the best, or even their public speaking skills, which you do need in jobs. You need to be able to talk to other people. I could personally work on some of my interaction skills with others because I'm not amazing at it at the very moment. Right. This could also be a big one, is that internationally trained engineers might be immigrating to Canada with the assumption that an engineer will always be able to find a good engineering job after arrival. There was a part in this paper that indicated a large number of international engineers who come to Canada are not employed in engineering, so they could be skewing this number even higher than it would have been if you just considered domestic engineers. So, this paragraph is extremely important. It kind of tells you that by and large, engineering programs do not incorporate mandatory co ops or other on the job components in their curricula. And luckily for me, my engineering program does include some form of mandatory co op. Well, not exactly mandatory, which I think is the catch here. We don't exactly have to do co op. You can just drop the co op part of your degree if you don't fulfill the requirements and graduate a normal degree. But if it was mandatory and the university really, really pushed students into it, there would probably be a much higher match rate between engineering degree holders and people with jobs in engineering. Other OSPE research confirms that employers overwhelmingly prefer to hire engineering graduates who have co op experience. So here's the figure 4 here kind of shows what I was explaining before, that engineering actually does quite well when you compare it with other undergraduate degree holders. So here we have percentage of graduates working in their applicable field of study. Engineering is pretty good, business is pretty good, and math slash computer slash information sciences is also pretty good. But the other ones here, social behavior, humanities, physical and life sciences, these have extremely low match rates and much higher underemployment rates than any of these other three. So engineering is still doing pretty good. I'm honestly surprised to see this out of business, but I guess there are quite a few business jobs, and engineering is very niche and like specialized in any job that you get. So you kind of have to already know what you're doing before you get into this job. And I honestly think that I would guess that people in business are more willing to train their new hires because it's probably not super expensive. Meanwhile, in engineering, you could invest tons of money and hours into somebody and they could just decide to leave because they don't like the job. So, I don't know, that's me speculating. No research has been done to prove that point. Another observation that I was kind of mentioning before is, do employers look favorably on individuals with engineering degrees because they have educational foundations in analytical thinking and problem solving? It can be argued that the two fields of study whose graduates have the lowest rates of underemployment are most likely to be viewed as analytical based: engineering and mathematics slash computer slash info science. This suggests that employers desire technical computer math, analytical, and problem solving skills, which again furthers my point that if you want a decent job with any undergraduate degree, engineering and STEM are very good places to go, but more particularly tech based analytical thinking jobs. Here's an important point when we get to the overall income of engineers and engineering managers compared to jobs in other fields. If you go towards the bottom here, you can see that incomes of engineering degree holders working as engineers or engineering managers did indeed compare favorably to income levels of engineering degree holders in non engineering jobs. So, if you have an engineering degree and you're working in an engineering job, you are more likely to make more money than if you are working a different job. So it's also favorable to your income to go work as an engineer. But as I showed you, there is a lot of people with an engineering degree not working in engineering and therefore being underpaid. So it seems that we still haven't come too far because women uniformly earn less than men in the same job categories regarding to engineering. For civil, mechanical, electrical, and chemical engineers, they earn 16% less. For other engineering, it was 15%, and as engineering managers, it was 17% less. So that's still, we got quite a ways to go to fix that wage gap. Okay, I think I'm going to call it there. Thank you for watching this video. Hopefully you learned a thing or two and it was interesting. If you liked it, leave a like, subscribe, and I'll see you in the next one.